Yes, it's saying setting up your meeting. So that means it is going through. Awesome. Yes. We are, okay, Yash, we are live. You can take it away. Yes.
Hi everyone, welcome to Weekly Wed from Business School of AI. Weekly Wed is the international speaker series that happens every Wednesday at 9 a.m. Pacific Time. Weekly Wednesday hosts experts across various domains like artificial intelligence, autonomous vehicles, and IoT. We recently had the IoT Women Day yesterday, 24 hours, 24 women, and now we are at Weekly Wed. Weekly Wed caters to the students of Sudha from Stanford, Barcelona, Elisava, and many of the students who she mentors. And today we have a very special speaker with us, Usha Rengaraju. Usha will be talking to us about AI for autism. And firstly, I would like to introduce Usha. Usha is an AI consultant. Yeah. Uh, Before that, I want to introduce myself. I'm Yashaswani. I'm the host of Weekly Vet for today. And I'm from Bangalore, India. And I'm an AI researcher here in Bangalore. I have been a Sudha student. I have been Usha student too. And it is a nice day for me to host my teacher here for my other teachers speaker series. So Usha
Yash,
is an
sorry
yes,
to interrupt. This is being live streamed, so we just want to make sure people understand what it means. So, can I just come and say that for a minute? Um,
yes.
okay. Uh, Hello, everyone. So, I'm Sudha Jamte. I'm just going to sit in here in Zoom. I'm one of those lucky people. I'm sitting in Zoom and can ask questions. And there's some of you here on Zoom, and if you do not want to be in the recording, like I will get into the recording like this, then don't come on video. And if you don't want your voice recorded, don't speak up. But you're here in Zoom, which means you can ask questions, you can chat. If you're okay with it, you can come on video or ask questions. And this is streamed on YouTube and LinkedIn. So I'm going to go watch LinkedIn, and if you have questions, I comment, add there. I'm going to bring it to the speakers here. I'm going to bring it to our host Yash here. Okay, and tag a friend. If you come back, watch it. That recording will stay put. Okay. Okay, back to you, Yash.
Yes, Sudha. And I will quickly introduce Usha now. Usha is an AI consultant, corporate trainer, and she is the world's first woman triple Kaggle grandmaster. Usha specializes in deep learning and probabilistic graph models and was also one of the judges for Tiger Graph for All $1 Million Challenge 2022, and judge for Intel Open API hackathon organized by Intel Software in 2022. She is ranked as top 10 data scientist in India for the year 2020 by Analytics India magazine, ranked as top 10 women data scientists by Analytics magazine in 2021, and also in as the 150 AI leaders and influencers by the 3AI magazine. She organizes Neuro AI, which is India's first ever research symposium in the interface of neuroscience and data science. She also organized the Neurodiversity India Summit, which is India's first ever conference in neurodiversity. She is one of the winners of ML in Action competition organized by the ML Developers Programs team at Google, and she has won the first place in Women in Data Science 2022 Datathon organized by Stanford University. She is also the winner of Kaggle ML Research Spotlight for 2022, winner of TensorFlow Community Spotlight 2023. A unicorn data scientist with strong foundation in economics, finance, business foundation, business analytics, psychology, and over 10 years of industry experience. She possesses great public speaking and writing skills. She is a champion athlete and has represented Tamil Nadu in national games twice. And now we would like to have Usha here with all of us and talk to us about AI for autism. And Usha, we are very happy to have you here. Our first question that comes to my mind when I hear the word autism is, how is autism defined? I hear that autism is part of neurodivergence, and we no longer call autism as autism. We call it as neurodivergent, and we have a very um, inclusive structure everywhere to have neurodivergence. And um, so, how do you define it?
Thank you so much, Yashaswani, for inviting me for this session and for even organizing a session on AI for autism. And it's Autism Awareness Month. April is Autism Awareness Month, so it's the right time to organize this session. I also thank Sudha Jamte for also organizing and giving me an opportunity to do this session. And to define autism, I would say autism is a spectrum condition. A lot of people are not aware that autism is a spectrum conditions. So the moment you spell the word autism, the first thing at their subconscious mind which strikes them is, a figure of a person who is intellectually disabled, who cannot walk, who cannot speak, and who cannot do their day-to-day activities. This is a kind of a picture which, comes into the subconscious of anybody, immediately when you say autism. But the fact which not many people are aware is autism is a spectrum condition. So there are people with varying abilities and skill sets on the spectrum. There are people on the very high end of the spectrum where they might be fully be able to do their day-to-day activities. They'll be going to university. They would have graduated from university. Some even go on to get PhD as well, and they also work in organizations. But they might have difficulties in understanding social cues. They might have difficulties in understanding the environment around them. They may face some challenges in the social space, but they will be able to do their day-to-day activities. They would have gone to the university, graduated, and all that. There are people on the lower end of the spectrum who require a lot of clinical intervention, like day-to-day activities. They cannot carry on their day-to-day activities without the help of their parents or caretakers. So every person on the autism spectrum is different. That's why it's very complex condition, because we cannot come up with general set of uh, you know uh, symptoms or things like that, because every person on the spectrum is very, very different. But they do share certain common characteristics, like most of them will have difficulty in understanding social cues. They might have difficulty in understanding indirect language. They may not understand jokes. And these are like common symptoms of autistic people. They also have difficulty in maintaining relationship. Orderliness is a big challenge for certain people, and they have sensitivity towards light. So these conditions vary from where they lie on the spectrum, and it varies from individual to individual, but these are common characteristics of most of the autistic people. And yeah, the point which I like to highlight is, when somebody says autism, people immediately start imagining a picture of somebody who is intellectually disabled, and who cannot carry their day-to-day task. It's not true. There are a lot of people on the higher end of the spectrum, like Elon Musk was openly autistic. Bill Gates, and you also have Steve Jobs. There are all rumored to be autistic people. And most famous, Lionel Messi is one of the best footballers we have in the world, and he was diagnosed with Asperger's, which is actually autism on the higher end of spectrum. The other name for autism on the higher end of the spectrum is Asperger's syndrome. So he was diagnosed with Asperger's syndrome when he was 3 years old. So he's one of the most famous footballers in the world. So they're highly skilled and highly talented people. Temple Grandin, she is one of the public figures in US, and she's also a veterinarian. She has done a lot with animals and that space a lot, and she's one of the reputed figures in that space as well. And she's also a person on the higher end of the spectrum. So this is a point which I like to highlight here.
Thank you, Usha. Thank you for that awareness and introduction that you gave about autism. We are moving towards a more inclusive society. We are moving towards a more inclusive AI also, where AI considers everybody on the same footing and works well for everybody. But today, we are here to talk about how AI can be used for autism. And my first question is, how can AI contribute to early detection and diagnosis of autism spectrum disorder?
Sure. Thank you so much for asking this question. So it's a very, very important question because early detection is very, very important because a child's brain takes about 5 years to fully develop, and the prefrontal cortex takes really, really long time to develop. So when you can diagnose autism at 12 months to 18 months, there's a higher probability you can put the child through a lot of intervention programs. There are plenty of early intervention programs, and US is the best place for this. All these early intervention programs. There are close friends of mine who had autistic kids, and they have given the right intervention programs at the right time. Like when the kid was like 8 months old, they started the intervention program, and now the kid is one of the toppers in the school, is able to do everything independently and things like that. So early intervention is very, very important for autistic kids, and 12 months to 18 months window is a very perfect window. And there's a lot of things where rewiring can be done very easily, and that is why. And how AI can help in this spaces, there's a lot of research from Stanford University. There are even papers which are published here, which says that early detection of autism is possible from the mother's MRI scan. There are biomarkers which can be identified from the MRI scans, and which can be definitive of autism diagnosis. But the research is still in a very, very early stages. And so this is one of the ways where AI can be used to, diagnose autism. The other ways, when I interacted with clinicians in hospitals, and especially in Bangalore, so the other ways where AI can be used is, you can even take videos of the child, and then pass it through AI. So a child with autism will make the right, and will have difficulty making eye contact, and the fidgeting. There are a lot of symptoms which you can easily identify as markers for diagnosing autism. So it can be also done through video analysis, observing the child for a longer period of time, and then using AI for video analysis. Also, you can diagnose autism. That is how the doctors are currently diagnosing in Bangalore. They, make the child do a lot of tasks, and they observe the child over a period of time with these tasks, and that's how they are able to identify autism. So use of computer vision will be very important if you're using video to analysis. But if you're using MRI scans, again, it's going to be using computer vision to, you can identify biomarkers from MRI scans and diagnosis. So this is my perspectives on the first use case. Yeah.
Thank you, Usha. And thank you for highlighting the need for early detection and diagnosis. Now, going to the next question is, in what ways are AI-driven interventions personalized for individuals with autism?
Sure. One of the ways where AI, if you want personalization, then there's a lot of robots which are available out there in the market. Especially there are a lot of robots which are manufactured in Texas and United States, and it's cost around $5,000. So these kind of robots are very personalized for the individual kids. And for example, if you want to teach the kid social cues, and if you want to teach the kid emotions, so continuously the robot will be displaying a specific emotion in their board, in their chest or something like that. It will show different kinds of emotion, and the child has to identify what emotion it is and things like that. So this works with robots instead of their own parents. The reason is because the autistic child may not, it might take like the child like 30 minutes or 40 minutes to even get into the zoo, and the child might may not like do everything, whatever the parents ask the child to do. So it might take, and sometimes if the parents are working, and they might get exhausted, and they might like break down at a point of time. But the best part of the robo is the robo can repeat the task even 100 times and may not get angry. And so that works really perfectly well for an autistic kids, because sometimes you might have to repeat the same work for 200 times for to get even a response from an autistic child. So that way, training with robots has been found to be very effective, and there are a lot of robots in the markets for individual kids. And the US schools, they already use robots for teaching autistic kids social cues, manners, emotions, and all of this is taught by robots for the autistic kids. And so this is one of the ways where we can personalize teaching for individual kids, and train them.
Usha, when you talk about robots, the first question that comes to my mind is, can AI understand the diverse spectrum of autism, including the differentiation between high functioning autism and other forms of autism? So we are looking at, does AI understand it?
Uh, no, the AI may not understand it, but these robots are just like a set of programmed kind of games and things like that. So the games might be like it will keep showing an emotion, and the child has to identify which emotion it is. Or it might show, and it might say an alphabet for people who are not non-speaking autistic. For them, it is very important for them to identify the alphabets and things like that. And so for those people, like it might show, it might say utter an alphabet orally, and the child has to go and touch that particular letter in a stencil and things like that. So it might only program a certain task, and the pace at which it does gives these commands and everything can be fine tuned, or can be programmed according to the child's needs. Some childs can do it, like children can do it really fast. Some children, you might have to pace it at regular intervals and things. There will be a lot of customizations which is available on the robot assets to do these pre-programmed tasks. Like you can modify certain configurations and assets, that's all. But the AI as such may not be able to understand and what the spectrum condition of the children as well. In fact, it is very very difficult even for the physicians to diagnose children correctly. So one of the biggest problems we are facing with autism diagnosis is misdiagnosis. The percentage of misdiagnosis in autism is very very high, and so that's a very huge challenge. Even humans find it very difficult to diagnose. The clinicians themselves find it very difficult to diagnose autism. We have still not in that time zone, I mean, era of artificial general intelligence where robots can identify. We've still not reached that space.
Okay. Now, talking about AI, and one of the um, characteristics of autism that might be there in certain individuals, that is social skills. Is there any um, is there any possibility of AI technology that can support the development of social skills in individuals with autism?
Yeah, definitely. There's a lot which AI can help when it comes for improving social skills. So if you break down the social entire phenomena of socialization, the first thing is you might have to understand what the other person wants. That's the first step. So only when you understand what the other person wants, you can communicate that from your end. So autistic people, where the blockage happens is, first thing, they cannot understand the other person's facial emotions itself well. And sometimes a lot of non-autistic people communicate through social verbal cues, like they are like they might show like if they're angry, they may not they might show it in their face, and all these. But autistic people may not be able to infer that anger from their facial expressions and things like that. And some people might show it in the tone of the voice. Again, it's going to be very difficult for autistic people to understand the different tonalities. So if you're not telling them explicitly, I am angry, and you're telling, you're conveying I am angry through by increasing your tone of the voice or something like that, there's high probability the autistic person might not get a higher probability, because every individual is different. And that is, since they're not able to understand what the other person wants, they're not able to communicate effectively. So that is where the problem arises. So the first step in developing a good social connection for that is to understand what the other person wants. So sometimes a lot of non-autistic people tend to communicate a lot through facial expressions, verbally, and sometimes when they type email, they use a lot of sarcasm or jokes and things like that. For autistic person, indirect language in text is very difficult. You have to explicitly mention everything directly, small sentences, very very direct sentences. This is it, I am angry, do this, like that. Very explicit direct sentences is very important. And we can have, like, for text emotion reduction, we can have, like, kind of a browser plugin where any email or any text comes, we can identify if it's a sarcasm or if it's a sadness or if it's an anger, what kind of emotion. We already have a very good benchmark data set called Go Emotions from Google, which can identify 27 different emotions. And so this is for text emotion detection. And for facial emotion detection, again, we have got very good data sets available out there. Benchmark data sets, there are plenty of benchmark data sets, celebrity faces data sets. There are plenty of, for facial emotions, we have huge number of benchmark data sets available. So again, you can build an AI algorithm which will identify facial emotions very easily. And this, how the autistic person can consume in the form of a spectacles or some kind of a chip near their head, where that particular component will, identify the facial emotion of the opponent person and then convey it to an autistic child. So this was already there as a tool. If you remember Google Glass, which had come out earlier, which was in the market earlier, but right now the shut down, it was doing exactly this. So the autistic, it was used by majority of autistic people, kids, and the autistic kids will wear the glass, and the glass will identify the facial emotions and it will convey it to the autistic person. This is anger, this is sadness. Once the child understands it's anger, then the child will, change the behavior. But the child is not able to change the behavior because the child has not understood it as anger. So this is where AI can help, and the second reason is the same thing applies for voice. And if the autistic child is in a phone call or, directly, want to identify the emotions in a voice, again, we have RAVDev's data sets, which is a benchmark data set, and you can, apply any, audio classification algorithm on top of it, and then you can do voice classification, emotion classification in voice as well. And the second once you understand the mo and the right, another reason why AI should be used is, see, if you see autistic people, for them these are skills which don't come naturally. And so they have to exhaust their mental energy, they have to exhaust, every person has got a limited number of mental resources. They would be exhausting 90% of their mental resources to just understand the emotions of the other person. So if you give them AI based tools which will do this job for them, they can use their 90% of mental resources to do more productive research work or innovative or the work which they really love. So it can also take that exhaustion out of them, do the heavy lifting for them as well. So it will work favorably in a lot of places. I think tools like Google Glass, hope they come back into the market, which will help a lot of autistic kids.
Usha, during the IoT Day Women program that we had yesterday in the panel discussion, you mentioned about the GitHub repo that you have created with many applications related to AI for autism. Would it be possible for you to show it to us so that we get a peek into the work that you have done and it inspires us to do more work in AI for autism?
Sure, it would be my pleasure, and thank you so much for asking this. I would share my screen. So my screen sharing is disabled at the moment.
I think now you'll be able to share the screen.
1 second.
Yeah. Can I share now? Yeah. So I'll just go. This is my GitHub repository. So my GitHub name is Usha Reng or Usha Rengaraju. You can put, and you can go to the repositories tab, and in the repositories tab you have the first one is autism for text emotion detection. So this autism for text emotion detection. So here you will have what the problem statement is about. So autistic people have difficulty in multiple modalities. So every use case you will have what the problem statement is. Here I've used three different models. One I have used mobile bird. I've also tried to solve the same problem using the recent LLM, both closed and open source LLMs from Google I've used as well. So there are multiple models I've used for the same use case. And the models are
Is it
mentioned here, the data.
possible for you to increase the font a little bit?
Yeah, sure.
Thank
This is
you.
good. Yeah, yeah,
Yes.
sure. Thank so here you will find what the problem statement is, what the models have been used, and what is the benchmark data set, linked to the benchmark data set, and the references section as well. So if you want to understand about the advocacy side of it, why the use case even exists, we have like around 150 videos from the clinicians collected over years, like in all these Neurodiversity India Summit. All these videos are freely available in YouTube, and we had physicians, we had neurodiverse people themselves, and we have non-speaking autistic people on the higher end of the spectrum. Several successful autistic people come and share their stories. So if you want to know the background of what problem the autistic person is actually solving, you can scroll through these videos. You will get diverse perspectives. And now when you scroll through, you will actually have the three different models are there in three different notebooks. One is the Keras notebook, and the other is Keras is a legacy right now. Keras, the old Keras. The currently we use Keras 3, which is same multi backend framework. So you can use PyTorch, TensorFlow, and JAX. You can use different backends with just Keras. So it's called Keras 3. So it is done in Keras Legacy and Keras 3 as well. And it is done using these recently released Gemini, Gemma LLMs as well. So you can go into these things, and this is the first text emotion detection. And similarly, you will have for the other use cases as well. I'll just take and show that as well. So the first use case is that. And the second use case is here. So this is about facial emotion detection, and the next is the speech emotion detection. And you also have the MRI image classification. And so the same structure follows here as well. You have the notebooks in both Keras Legacy and Keras, what the problem statement is. So in this particular thing, I have taken a research paper. The research paper's original implementation is in PyTorch. So I have implemented it from the scratch in Keras. So this is first ever implementation in Keras 3. And you also have a demo in MediaPipe. You have the data set which you're using, Intel extension for TensorFlow and all that. And so you have the facial emotion recognition, and you also have the same way MRI, or yeah, this is speech emotion recognition. So speech emotion recognition, again, I'm using TF wave to wake model, and then you have the problem statement and you have the data set. And you also have the Hugging Face Spaces demo. So the implementations are there, but if you're not a very coding person and then you want to see the demo, then you can actually go to the demo page here in the Hugging Face. You can Hugging Face. My name is Tensor Girl, so you might have to search for Tensor Girl, and you will find these demos. So if you click on audio emotions, and so you can just give the input. You can type on a message. I am happy, and you want to see what emotions it is. It's a text emotion thing. I think there's some error here. We have to can see the emotions. I think there's an error, but I'll just fix that error. But if you go to Hugging Face and Tensor Girl is my name, so you'll have all the use case demos like there's an audio classification, MRA classification, and you'll also have the facial emotion as well. So Hugging Face demos are very handy where you can give the input and you can see, you'll be able to get the output as well. So you're not a very technical person and you want to just see how the model works and things like that, then you can just go to the Hugging Face spaces and see the demo. And so this is about the use cases, and this is about the use cases, and this is about the demos. And if you want to contribute to it, how can you contribute? So the main contribution here is you have the workflow already done for it. So you might have to either convert it into an Android application, or you might have to convert it into an embedded device application. For example, you might have to create a device which the autistic children can wear and embed the AI model in the device. So the model, the workflow, the data set, everything is figured out. But the product, ideation and how this AI can fit into the product. For example, a wearable glass, and the most easiest would be a browser plugin. So the entire text emotion classification can be quickly converted into a browser plugin. And so this is about my GitHub repository. So my name is Usha Rengaraju in GitHub, or Usha Reg. And you can also go to Hugging Face Spaces and you can check my name. And Hugging Face, my name is Tensor Girl. Yeah, this is about the demos.
Thank you, Usha. And also, thank you for explaining how we can contribute from the community and make it stronger and stronger day by day. This is getting live streamed on LinkedIn, and it will always be here for anybody else who is coming to learn more about autism and AI for autism, how we are leveraging AI technology for making the lives of autistic individuals life better. So, Usha, moving on, we have a question here. Sudha is asking, what devices can this be embedded? Can you tell a bit more about the devices?
Sure. So for facial emotion recognition, the best devices would be a glass. Because that would be the perfect angle at which which can capture the facial emotions of the opponent person. So I mean, instead of using a multiple devices, we can just use a wearable glass which can where the say the facial emotion model can be embedded, speech emotion model can also be embedded, and both the models can be embedded in a single device. And so the glass would be the perfect devices. So you might have to take any glass which is out there in the market, and then find a way where these embedding IoT devices can fit into this glass where AI model can be embedded as well. So this integration of the components has to be taken care of. I'm not very familiar with the integration side and the embedded devices side, but in my opinion and perspective, a facial glass, I mean the glass which persons wear, that would be the eyewear would be the best for facial emotion and voice emotion. And for text emotions, a browser plugin can be do. It can this already the entire workflow can be easily quickly converted into a browser plugin, and the autistic person has to just install the browser plugin, and that would be taken care of.
So you mentioned an example of a robot being able to help the children when you got started. So
Yeah.
I'm so happy when you said the embedded devices, because I was just thinking, okay, you have this, because typically what happens is when we hear about AI models, ML models, it's a piece of code, right? Nobody's going to come to a Python and then pull it out, right? It has to be exported in some form, and then the output is typically put this on a website or put this on an app in some form that calls for development. So when you said embedded devices, I was just wondering, is that how it will go to a robot also, right? Like if somebody's watching this and I see a bunch of developers who have also joined recently, they're brilliant people doing different things, not in the autism space, maybe. And I also have students who are in the IoT space. So I was just thinking, somebody who's looking at your GitHub can get the code output or build on it, right? 4 can build on it. Now, how would they connect to the robot was my thought process. That's where the question on embedding came from.
Yeah, sure. Thanks so much for asking this question. There is one robot which is out there in Texas in US. The robot name is called Milo. And right now it costs about $5,000. And how this entire functionality might function in a robot is robots might have certain cameras for capturing input about the child. So these cameras might capture the child's movements, facial emotions, and the child behavioral patterns. And so the video or the live stream would be captured through these cameras, and there would be a video analyzing software which is using AI. There would be a video processing software which would convert the behavior and give the commands, the intent of the child, or what the child is doing. And based on this, the robot, it can take feedback based commands on what to do next. And the other way is, if there be like different buttons where right now we want the child to train on different emotions, and the robot just will have a glass kind of a screen in the chest, and
Yeah.
it will keep showing the different emotions and things like that. So there will be different configurations. So now we just have to click on the robot. Now just train the child on facial emotion, and then it will start doing that task. And so this is how the communication from the child's behavior can be captured through cameras, and AI can be used for video analysis. So the robot will also get input on what the child is doing. And for programming, for the explicit behavior of the robots, there can be explicit configurations which can be clicked, which can be the robot can get as an input, and take the next call the corresponding AI models to do those tasks and
Yeah.
things like that.
Yeah. So the Milo one is a commercial one, and they might have something else in its brain, right? The emotion detection module that they are using could be proprietary. So somebody watching this could actually take your, I'm just thinking this, somebody who's watching this can take your GitHub code and then go create an interface of some kind so that it can really,
Completely
yeah,
open source models,
yeah,
and so it will not cost them anything. On the AI side
yes.
would be completely free, and it is just that for the robot components they might have to spend some money. Yeah.
Okay, thank you, thank you.
Thank you, Sudha. And Usha, moving on to the next question. We talked about social skills. Now, the next aspect that comes to my mind when I think about autism is the sensory processing issues. So, is there anything that AI can do, any AI tool that can assist for sensory processing? I know this is way beyond what we have in 2024, but if there is some futuristic tool that you know, or an idea that you have, or a research that has been done, we would like to know about it.
Thank you so much for asking this question. This is very important question because this is an area where we require a lot of future work. So most of the autistic people have extreme sensitivity towards noise. Either they can tolerate high levels of noise, or they cannot tolerate it. They have zero tolerance, or they have very high tolerance. So some people will have tolerance beyond the human capacity. So humans can only have certain decibels, their hearing range. So they can tolerate noise even beyond the hearing range, and some people can not tolerate this. So these are the extremes for the autistic people. And there are like certain lighting technologies which can dynamically adjust based on the needs of the child and all that. These are researchers which are in the very very early stages, and the very very handful of research papers which has come out. Nothing is open source, everything is proprietary in these research papers as well. And so we require a lot more research in this space on how to make. And one thing which I find a lot of conferences doing it is they want to make it more neurodiverse friendly conferences. So if you see like most of the conferences will have silence mode, so they'll all have the headphones on, and nothing will be heard outside, right? So that is one of the ways where you can make your conferences or events very neurodiverse friendly, because if it's huge noise and things like that, the people might have very high sensitivity towards noise. And so there are small adjustments like this can help at this point of time, but there's not much of a concrete research with respect to noise sensibility, lighting sensibility, and things like that. And some autistic people even have sensibilities, I mean, sensitivities towards food also, texture of the food and things like that as well. So these are all in the early stages of research right now. Something which works for the individual has been tried out and taken care of, but there's nothing like very concrete set of product which has come out which can help a lot of people. Nothing much has come out in that space. I'm sure like people who are watching this might come up with interesting ideas to help tackle that problem.
I think that is the whole point why we have sessions like this, Usha. We bring in speakers from all over the world to tell us how we can contribute, how we can do research in these directions. What is it that we can put in such that there will be a delta change and we start the ball rolling? And the moving on to the next question is something that's close to my heart, and that is ethics and AI for autism. How do you talk about the privacy? Is there an infringement of their privacy when we have monitoring or assisting tools which cater to the autistic individuals? What about the privacy?
Yeah, sure, sure. So this is very, very important thing to talk about. One of the thing is data collection has been a very, very huge problem when it comes for autism. A lot of research in autism is stagnated because of data collection. And the reason why data collection is challenging here is, even if you endorse like differentially privacy way of differential privacy or federated learning, there are plenty of other privacy preserving machine learning techniques. Even if you are willing to incorporate all those techniques, here the people are in the first place not interested in letting their child being videographed. And they would sometimes, we have seen parents signing up the consent form and then coming after 2 days and just backing it off, and one parent backs off, every other parent backs off as well. Collecting the data itself is one of the biggest barriers for conducting autism research. And so definitely, I think when it comes for healthcare data, we have to be very, very important not to, expose any personal details about the individual and all these things. And the parents are generally very protective of their child. And for autistic, parents of autistic children are even more scared. And so, we have to ensure how the data collection happens very, very securely. And once the data collection happens in a secure way, then how the database being used for modeling, what kind of privacy preserving machine learning techniques are used to access the data for building models. I think there are plenty of techniques which are available specifically for dealing with healthcare. The same things works here for autism related use cases. Whatever is applicable for general healthcare model building might be applicable, how the data is being accessed for building models. And so this is about the, and the by, I mean, when it comes for creating synthetic data, again, there can be a lot of hallucinations which can happen. So there are certain areas where mistakes can be tolerated, but healthcare is one space where mistakes can end up being very costly. Imagine, we build a model based using a synthetic data set which is being generated by some kind of a diffusion models, image generation models, and that's very faulty model and that's hallucinating. And we build another faulty model on top of this faulty data set which is being generated. And that gives a wrong diagnosis. An autistic child is not being who's autistic is not diagnosed as not autistic or diagnosed as some other clinical conditions. If it's misdiagnosed, then getting different treatments, and that treatment, certain people, just because they got a mistreatment, might end up even losing their life. So this is where there are cases where having mistakes may not result in death or fatal conditions, but there are certain situations in healthcare where making mistakes can actually be very, very fatal. So I think autism is one area where, having any form of bias in the form of synthetic data creation or the data set generation in all these spaces can turn out to be very, very fatal. So we have to be extremely careful when it comes for data collection. And how we use those models might be a lot of very big concern for parents who have let their children being videographed and all that. Fortunately, we have very good privacy preserving machine learning techniques for healthcare, so that is good. And one more thing which I say is there's a lot of huge investment which is required to prepare benchmark data sets. So those are areas where, see, there's one data set which is come for MRI image classification data set. And so there's only one data set right now we have for MRI image classifications, and that has been like compiled by 16 neuropsychiatrists and neurologists across the globe, because we cannot collect data sets only from autistic children in US and train a model and then use it for detection in India. We cannot do that. When we collect the data set, it has to be geographically distributed equally as well. So all of this requires a lot of funds, a lot of sponsorship. And only then a lot of more benchmark data sets will come out. If a lot more benchmark data sets come out, then there's scope for a lot of researchers to use these benchmark data sets, do a lot more research. So the first step is the data sets collection. So for which areas like autism requires a lot of sponsorship. And if the universities get a lot of funding for research in these niche areas, then they can come up with benchmark data sets and open source it, which will give the opportunity for researchers across the globe to come and conduct research on these areas as well. So for data science, I think all of it is going to start with a data set. So I do hope people who are watching this might put more focus on creating more benchmark data sets for autism.
Yes, thank you, Usha. And I really hope this little bit that we are trying to do now will snowball and become a big thing someday and make a difference in this landscape. Now, as a follow-up question I have is, when people are creating AI, general AI for everybody, how important it is to consider autistic individuals, neurodiverse individuals, and incorporate certain techniques and mechanisms such that even they can use it.
Sure, sure. Thank you so much. And for asking this question, this is a very, very important question which is being ignored by a lot of organizations. Because a lot of organizations explicitly show themselves as an advocate for autism, supporters of autism, but they don't put in as much effort to cater their product to autistic individuals. This is an area which is highly ignored, and thank you for bringing this up area. So I, as an advocate for autism, I have traveled to a lot of organizations across India to give sessions. And out of all the organizations, there was only one single organization in Bangalore, which is very famous for Photoshop and things like that. Only one organization where the attendees were explicitly product managers and UX designers came and sat in the event. The reason why they were sitting in the event was because they wanted to understand more about autism, so they can cater to like building more products which is more inclusive and things like that. So there are small things, the colors. So autistic people, some people have autistic kids tend to have affinity towards brighter colors, and and visually presenting a lot more, instead of having too much of written language, visually having charts or diagrams to explicitly tell certain information instead of not putting more textual information on a web page. And the colors can be very important, like having like bright colors in place. And even the way the content is distributed, if it's going to be too clumsy and cluttered, it will be a huge turnoff for an autistic person. And they wouldn't even come to that space. And there are a lot of autistic people who struggle with GitHub. So the way the GitHub is organized and things like that, it can be like very small letters, and too much of clumsy, there's too much of icons and things like that, it might put them off. Not many people will come. They just will have a negative affinity towards that particular UI design as well. So it's very important to, once you generate a product, it is very important to do testing, feedback testing, user feedback testing with individuals from different abilities and stuff. And if you want to cater it to a neurodivergent people, then you might have to do user feedback testing with a group of neurodiverse people across the globe from different geographies and cultures as well, to make it more inclusive. This is one thing which is highly ignored by many organizations, even organizations who are explicit supporters of autism, but they don't like bother to make their products exclusive. So thank you so much for bringing this topic. This is something which has to be talked about.
Yes, we have been doing research in the area of inclusive AI. That's an area which is very close to heart, where we consider everybody. And Usha, to close out today's session, can you tell us more about neurodivergence and what each of us as technologists, researchers, scientists, what can we do and how can we contribute? Each of us who is seeing this video on LinkedIn and in Zoom.
Yeah. So this is a high priority issue. So there's a very low priority which is being assigned to neurodiversity advocacy or neurodiversity awareness. So the priority is being very less, but the priority has to be high. I'll give you a couple of reasons why the priority has to be high is because we talk about extension of animals, we talk about extension of plants, but there is going to be an extension of autistic people. So there's a lot of statistics which has come out. This is proper research. You can go to the research paper, check out the statistics by researchers. Autistic people have 85% probability of doing committing suicide. This is a proper research and study which is being conducted across the globe. And there are several countries which has legalized assisted suicide, and the only country which gives the openly the statistics of people who are doing assisted suicide is Netherlands. So according to the Netherlands database, the huge number of autistic people who are physically healthy, who have graduated from universities, who have a job, and who are physically healthy, doing everything like every other person, but are autistic and are facing huge mental, challenges and social cues and all these things. There are kids who are like 20 years old, and there are women, very young women, like 28 years. Recently, there was a viral article. They're all taking up assisted suicide because for them it is there's not much of clinical medicines and therapies and innovations which is coming up in the space. And for a lot of people with these conditions, since they're not getting a right therapy, they're not getting the right kind of treatment, especially in India. Things are very, very good in US and in Europe comparison with countries like India. So there's a lot of suicide and things. That is why it has to be a high priority issue, since the suicide rate is very, very high, and people start taking it more seriously. And AI can definitely help make autistic individuals life much more easier. So autism is a condition which cannot be cured. The autistic individuals will face challenges throughout their lives, but we can use technologies in a meaningful way to build products which can help them navigate the challenges in a navigate the challenges and live more independent life. And that is where AI can help. And I do hope, and I'm sure a lot of people whom I have interacted with, being a professor and adjunct faculty at a lot of places, what I have noticed is a lot of students want capstone projects. A lot of students want have time. They want to contribute to the social good, but they don't know what cost to take it up. So this is a very good cause. So if you're looking for capstone projects or research projects and you want to get started with the research, this is a very, very good cause to get started with. And and I would like to thank Yashaswini and Sudha, both of you, like for giving me an opportunity, to talk about this session. And this April is Autism Awareness Month, and you're doing it at the right thing at the right time as well. Thank you so much.
Thank you, Usha. Thank you, Usha, for this wonderful session. I think this is just a start, and our interactions can grow with the community, Weekly Vet community, and we can have a thread about autism and how we can come up with technologies for assisted living. And this is wonderful to have you here. And as I mentioned, this
Yes,
is
yes.
yes, Sudha.
We actually have a community on Business School of AI .community.teachable.com. So I'm actually creating a thread for AI and autism. So if somebody wants to work on data collection or somebody wants to collaborate on a project, I would like to see that robot thing because we have some people in our community who are working with robots, experts in that, and a lot of people with IoT who know to do embedded systems. So if there is an interest of people who are watching this, I've just put the link here. I'm also putting it on LinkedIn so that we can continue to pick up. And Usha, we will come back to you and maybe ask for help, but this is amazing. Thanks, Yash.
So much. I would love to help and mentor those folks to take their product to completion. Thank you so much for proposing this as well.
Thank you, Usha. And thank you, Sudha, for making this platform where we bring speakers from all over the world and we understand their perspectives and learn. There is a very important saying in old mythological stories. They say, people are like books. We learn from people more than we can learn from any textbook or any device like that. So today we have learned a lot from Usha, and Weekly Vet is all about learning from people and making each other's life better in this whole society. Thank you, Usha. Thank you, Sudha. And thank you, everybody, for joining Weekly Vet. We will meet in the next Wednesday at 9 a.m. Pacific time.
Sorry, Yash, we are actually meeting at 8 a.m. Pacific time. I think that confusion was because of the time change we do in US. It's 8 a.m. Pacific time.
Okay, 8 a.m. Pacific
Yes.
time. Yes.
Just now it is 9 a.m. for us. Yeah. We finished
We
at
will,
9 a.m. Yes.
we will meet at 8 a.m. Pacific time.
Thank you.
Okay.
Okay.
Thank you, Usha. Thank you,
Okay.
Sudha. Bye.
Thanks, Usha. Bye.